How do we basically build RAG systems with mixed data documents? Now, this is oftentimes a use case and a scenario that you will face in the real world, right? So this is oftentimes a use case or a scenario that you will face in the real world where you want to work with mixed data documents. You want to oftentimes work with mixed data documents. So in all the demos that we saw until now, Tesla, Government of India, Azure, we only had text data. But in a real world application, you will not just have text data. You will have text, you will have images, you will have tables. And these are very, very common things that you will have in a PDF file, right? If you think about a PDF file will also contain these kinds of data. Even our current PDF files, if you see, our current PDF files also contain this data, right? So some of the content, if you see the OpenAI documentation particularly, or the Government of India report, the GOI report, if you see, many of the parts actually contain tables. Some of the parts even contain images. If you see the documentation, there are some pictures that you will see. Problem is the approach that we have followed right now that does not handle the pictures, that does not handle the tables. Now we would have thought that everything is getting working fine and successfully. No. The problem is whenever it encounters an image, whenever it encounters some other mixed data type that it is not able to recognize, our model has ignored that. So parsing is a very, very important part, right? So the vector DB creation happens a lot later. But the first part is how do you take that document data? How do you parse it? And then you do the chunking. And only after that, you go ahead and vectorize it and save it in a vector DB. So one of the most important parts of building a RAG application or anything for that matter, whenever it comes to any kind of document type data would be to do the parsing and the chunking. Both of them go hand in hand. You parse the file, you make sure that you read the file properly. Reading and parsing are going hand in hand because when we say read, that means you're basically parsing. You're trying to understand what is there in the document or the PDF. And that is not just a text-based parsing. You want to parse based on other forms of data as well. So this is the very real thing that happens in a parser. And now I'll give you a small flavor in terms of what other kinds of parsing techniques are used in practice, what other forms of parsing techniques are used. So you can see that we are using a parser. And the parser is taking the PDF document and it is parsing the text separately. It is parsing the table separately. It is parsing the images separately. This is also a very common strategy that is used. Because as I told you, a PDF file will contain different types of data. It will contain text, it will contain tables, it will contain images. So a parser, what it will do is a document parser will take the data, will read the document, and it will parse the text separately. It will parse the images separately, and it will parse the table separately. And then the chunking will happen. I think the chunks we are already aligned with how we do the text-based chunking. It will chunk the text separately. The same idea that we discussed. We use chunkers. Every 512 characters, we say, okay, let's say as an example, page 1 is chunk 1, page 2 is chunk 2, page 3 is chunk 3 based on the text. So we create chunks for text. We can also similarly create chunks for tables. And a simple example would be one row is one chunk. I'm just giving a very ballpark example. Each row is one chunk or each table is one chunk. Think of it that way. So there are chunkers. Separately, the chunking can be done only for tables. And finally, we can also do chunking for images separately. So we can say one image is one chunk. So these are the two additional steps that we are putting in terms of mixed data RAGs. So take the document, use high-end parsing applications, and the one that I will show you here, the one that I will briefly show you here is something called LlamaParse. LlamaParse is very, very popular. Okay, I'll show you a small example of LlamaParse, how LlamaParse can be used to parse a multimodal kind of a document, a PDF, where there are different types of data inside the PDF file, how the parser can extract the text separately, it can extract the images separately, it can extract the tables separately, and then it will chunk them separately. It will create chunks of text, chunks of images, chunks of tables, and then for each of those chunks, it will do the embeddings. And the embeddings will happen separately for the text, And remember, there are different models for each one of them, right? We are not trying to do anything. We are not trying to create these models. They're all pre-trained models. Just like I showed you yesterday, there are open the massive text embedding database MTEB benchmark, sorry, MTEB, massive text embedding benchmark, MTEB benchmark we have. So we've got text embedding models. Similarly, we have table embedding models and we also have image embedding models. So there are separate embedding models that will be used to create the embeddings for the text chunks, create the embeddings for the image chunks, and also create the embeddings for the table chunks. And finally, all that information will be part of the vector DB in an index manner. And now you can see how rich the vector DB will become. So now the vector DB has all the chunks and the respective embeddings, but this time the chunks are basically not just text chunks, but they also are image chunks. They also have tabular chunks. So different forms of data are now part of the vector DB. So this is how we think in terms of an application perspective, how we work with a multimodal RAG. Now, just to give you an example, you can actually see LlamaParse. LlamaParse is not very hard to explore. You can see LlamaParse in action. So LlamaParse is actually a very popular parser. There are many parsers out there, but LlamaParse is actually quite popular. You can go to LlamaParse and you can see at a very high level what they do. At a very high level, you can see that LlamaParse transforms unstructured data into LLM optimized formats. Very important, right? So it is able to transform the unstructured data into LLM optimized formats. So that is one of the things that LlamaParse is able to do. Okay, all of you can see the screen. Okay, so for example, if the original document looks somewhat like this is what the original document looks like on the left hand side. If the original document looks somewhat like this, after you use LlamaParse, the transformed document will look somewhat like this, what you're seeing on the right hand side. That is what the transformed document will look like. So if the original document looks like this, the transformed document using LlamaParse will look like this. And you can see how beautifully it has taken the chart. The chart is otherwise an unreadable data, right? This is usually not readable. This is not machine readable. I mean, so it's not text, right? So this bar chart is not actually a text. But see how beautifully uh, the chart embedding models have understood what is there in the bar chart and how they have converted that to a tabular or a text kind of form, which the LLMs can understand. So parsing is actually a very important part. So all your chunking and embedding happens after that. But first you need to read the data, right? So that's an important aspect of what LlamaParse does, right? So I'll just show you, like you can have to log in. You have to log in and then you have to see how it's working out, right? So let's just see. They give you some free limits. Okay, I won't be able to show you every part of it because this is a paid application, but it's just for fun. You can try it out and it's quite good. It's quite powerful, right? So this is the LlamaParse free plan that I've shown you right now. And you can also get the free plan. You can see if you click on it, you'll be able to see your usage, how much you've used and what kind of thing you've done, right? And you can see there are three things that they give you. One is for index, second for extraction. You can extract information from documents, and third is parsing. This is what we are interested in. We can go to the playground. You can click on the LlamaParse playground and you can actually see. There's also something called Llama Trace. This is all part of the Llama stack, by the way. Llama Trace is also a very, very popular thing for tracing, LLM trace. So it's basically used for LLM operations. So whenever you do an API call, so Llama Trace is used to keep a track of how many requests you're sending, any errors that are happening, all kinds of logs, how the language models applications are performing in production. So Llama Trace is very popular for this kind of LLM ops kind of stuff. Okay. Anyways, you'll see a lot of these applications which are starting with Llama, Llama Parse, Llama Trace, Llama Index. So they're all part of Llama. All right. Now, what you can do, you can try this out. You can upload any document and you can actually try it out. And what you can also do is you can set up an API key. The same way you can set up an API key. I'm not showing this part right now, but you can set up an API key and you can access Llama Parse from within your code. Okay, so this is just the playground interface, the user interface that you can see, but the same way you can do it in the code. And that is exactly what I have demonstrated to all of you in this particular hands-on. This is a very extensive hands-on exercise where I try to use a multimodal RAG for a research assistant application. Okay, so this is a very exhaustive demonstration which I've shown you, and this is what I will quickly take you through right now. You can all directly use this one. And just to add one more level of detail, just to add one more level of detail in terms of what we are discussing. This is the NVIDIA blog, and I actually kind of like this article a lot. If you just see, if you scroll all the way down, here also they give a very nice blueprint for multimodal retrieval blueprint for RAGs on PDFs. Okay, so all these are very new ideas, right? So you can see NVIDIA published this in 2024. This was like less than a year back, right? So whatever we are discussing right now in the class is actually, especially the multimodal part is very new. Okay, so LlamaParse and all this is very new. It's not like text-based parsing has been there for a long time, but the other aspects where you take a complex PDF file and you have got lots of different types of data. So this is something which is very new. And just like we are talking about LlamaParse, similarly, NVIDIA also gives a framework. And what is NVIDIA's framework? NVIDIA's framework is using the NeMo framework. NVIDIA has something called NeMo. Okay, and you can read about it. You can read about NVIDIA NeMo. So they use something called NeMo to do this. Okay, so you can read about the NeMo framework and how they use it. Okay, so this is the pipeline. I can open this in a new tab and show you. This is pretty much what we talked about. And you can see, uh, so PDF documents, we are first passing it through the PDF parser. And this is where we can, either use NVIDIA's internal NeMo, or we can use LlamaParse. Other kinds of parsers can also be used. And what it will do is it will parse it. So if it is a text data, there is no problem. The text will be taken as it is. You can see if it is text, it will be taken as it is. And if it is an image, uh, the charts, look at this, tables as images, because the tables are pictures, right? The tables cannot be read. See, if the tables can be read, it is okay. But if the tables are there in a picture form, that's a problem. Then you need to convert it, right? You need to convert it. So that is the idea. You need to convert it. Okay. So what am I trying to say? Let me see if I can maybe explain this in a better way. Okay. So for example, look at this. See, sometimes look at this one. This is the image, right? Now, if I go to this is a PDF file, this is a PPT. I can convert it to a PDF also, right? See, this particular text I can select, right? Can you see I can select the text? So all the text in my slide I can select. Look at this use case, all of you. See, I can select the text, right? So this is actually text. This is actually text. But this one, uh, you can actually save it as an image also, right? So if I go to file, let me show you what I mean to say. It will be better if I show you through an example. We can connect this a lot better. Okay. So I can actually save this current slide as a JPG file, and now you can relate to it a lot better. Okay. Look at this. Now if I try to select, can you select? See this? This is what I meant to say. So this one, if you see, I mean, for the human being, it doesn't make any difference because you will say, hey, Sayan, I can see the slide. But the moment you pass it through a parser, this can be read as a text. The machine can read this as a text. That is how your chunking was happening. It can process this as a text. Okay. But if you have a picture instead, if you have an image instead, the parser cannot read this as a text. I cannot select it. See, I'm trying to select. I'm not able to select. I'm not able to select. This is the image. So what you this entire thing is an image. Although this is a slide, I'm trying to copy. I'm not able to copy. This is the picture. It's a JPG file. You can't copy this. You can't read the text. You can't copy paste the text, right? That's the issue. And lot of times when you work with PDF files, if you have charts, you might have a chart where there is some text, but you're not able to copy the text because it's in an image form. And there, what you have to do is you have to use this kind of a framework, right? So the text will get processed normally, no problem. But if the page is in an image form, then there are two parts to it. One is there is a table as an image, and the second is there is a chart as an image. And so there are separate models that you have to use to, you don't have to use it. All these applications will do it automatically for you. There are separate models that you will have to use to convert your tables into a text form and convert your charts into a text form. That's the same thing that we saw in that original thing. No, remember I showed you that how LlamaParse is able to convert your bar chart into a text. So you're able to convert your image chart into a text, and you're able to convert your image table into a text. Now everything is text. You've got pictures, you've got tables, you've got text, and now the chunking will happen. Nemo is again specific to NVIDIA, but you can use your own chunkers. You can use your own embedding logic that we have discussed. We can use ChromaDB. This part is the same. And now we save the chunks in the vector DB. So we create chunks separately for the images, separately for the text, and separately for the tables. And now the other things will happen. Like this is the retriever. It will retrieve the chunks. The front end, the user will query, get the response straightforward. This is something else. This is what we'll talk about later, ranking, re-ranking. Okay, but rest of the flow we can understand. So this is just to give you an idea about the whole RAG pipeline in terms of advanced multimodal applications. So above part is the ingestion pipeline, how you read your data, how you parse, how you chunk, how you create the vector DB. This is often one of the most important and one of the most time-consuming parts. Once that is done, the retrieval pipeline is easy. It's easy. This is the easiest part. Now, this is the end-to-end application that I've tried to show you. So I've taken real data here. If you see, these are image papers. I'll download this and show you what type of data we have. And the objective here is I've shared the code in such a way that you can directly take it and run it. All these are perfectly working code samples. You can directly take these code samples and you can run it. But this is a more advanced exercise, so we won't be doing this in the session right now. But I have shared the exercises with you so that you can all try it out. The image papers, you can see these are real research papers that are given. Maybe for a minute, if people can read the business case. Okay, all of you can see this. Everyone has read the problem statement. So you can see it's a very real world use case where we are discussing how we can build a RAG application for researchers. And RAGs are a very, very good use case for researchers particularly. Imagine you're trying to research something, you're trying to write a research paper. And if you have done some research in your career, you will know it's very important to dissect information or retrieve information from different sources. Google was the go-to tool in the past, right? We have all used Google, right? We continue to use Google a lot. The researchers have to Google a lot. They have to go to different papers and different references, different links. They have to study different things, and based on that, they will do their research, right? So RAGs can be an excellent application area in this field. So what we are saying here is uh, the researchers can write certain queries, they can enter certain queries, and based on that, the RAG assistant will be able to automatically fetch the information from all the research papers and give them the answers. Okay, so this is a very simple use case where I only am showing you 5 PDF files, but you can imagine a more real world use case where we have tens of thousands and millions of documents, millions of research papers are listed in this particular portal, and anybody from the university or the organization can go and write a query and get answers based on their query, based on all the research papers that are out there. Okay, this could be a very, very good practical application. Just to show you some example files, you can see this is what the example files look like right now. So this is the first one, some functional vignette, memory part 2, role of medical temporal lobe, whatever. And you can see this is real world data. It's actually a real research paper. I've taken from the page number 846. It's a huge one actually. So I've only taken some small sample of it because these are all huge, huge papers. And this is the part I was mentioning. You can see these parts I can copy. I can copy and paste it. But these parts I cannot copy. Although this is text, if you see, I cannot copy. Like amygdala, hippocampus, okay, uh, entorhinal cortex. I cannot copy. This is actually in an image form. Okay, this is all very real applications. This is the image. So this document is a combination of text, pictures. You'll see some tables below. And if you try to use your normal parsers, you may not get errors, but it will not work correctly. This is one more example. You can see. Again, there's a lot of text data we have. And see, the data is some pictures, some references, some links, some table. This is a table actually. But this table is in a text format. But this is still a table, right? See, this is all images. This is in a text form. But some of them are not in a text form. So a lot of these practical applications we have here, actually. Now, what we want to do, we want to build the RAG system. There is something else we are doing in this particular exercise. We are actually installing requirements.txt. Okay. So all this file, if you see in all the previous code snippets, what we were doing, we were just using directly, we were doing pip install all the individual libraries. But here what we are doing is we are actually doing something called requirements.txt. So requirements.txt is basically a text file So you can see what the requirements.txt contains. It's actually a text file where all my libraries are highlighted. This is a very practical way how things are done in the real world. Okay, so if you're actually trying to deploy applications in Python or in Gen AI or data science or anything for that matter, so this is how you will do it. You'll not do pip install individual library names, but you will actually create a requirements.txt file, and in that requirements.txt file, it's a simple text file. You will list out all your packages. You will list out all your packages in this one single file, and then what you do in the main Jupyter notebook is you just go and say pip install requirements.txt. So see, pip install requirements.txt is what I'm doing. So automatically all these libraries will be installed. So whatever libraries I had here, all these libraries will be automatically installed. So right now I'm doing in my local machine. So we are not realizing the benefit or importance here. But the moment you deploy this application somewhere else, which I will show you in the second part of the session. So once you deploy this application to some other environment, okay, so once you actually do a real-time deployment to some other environment, so there you need to install the same packages. The same packages need to be installed there also, right? So there the requirements.txt will be a lifesaver. So there you don't have to individually install the packages. So whatever packages you have saved here, the same set of environment will be created there. Okay, yeah. But there are other ways to do it. You can use Docker containers and all that can also be used. So we want to ensure that whatever libraries and versions we used in my dev machine, so the same thing is used in my production system. Otherwise, your code will break. There are some things that you use which will not work in production. Okay. So unzip research papers, image papers.zip. This is the same approach that we used before. So you take all those PDFs and we use the PyPDF directory loader. This part is the same as what we discussed before. You can see. And this is the embedding model. These parts are very, very similar. And here I've actually used LlamaParse. Okay, you can go through this code. You can run the code as it is. It will run absolutely fine, but it will take a lot of time because the parsing part actually takes a lot of time. So you can do this later on after the class, but you can use LlamaParse to do the parsing and see how it actually parses images. I've saved the outputs here so that you can see what has happened. This will help you understand what has happened actually. So see how we parse the image objects separately. The images are separate. The tables are separate. You can see. So we have parsed the picture separately. These are the images. You can see. These are all the images we have parsed separately. .png, 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 height, width, and where the image is present. X, Y, W, H. This is the bounding box actually. So we have the image name. We have the width and height of the image. X, Y, W, H of the image. Where the image is present in the whole page. So similarly, we have also extracted. These are all the images you can see. So the first pass, we have managed to go through all the PDFs and extract all the images. And the next objective would be to take these images and create embeddings out of it. Okay, and there are different embedding models that are there for images. So people who are coming from a slightly deep learning neural network kind of a background, you understand there are CNN models that are used for this. There are convolutional neural networks that are used to take a picture, and from that image, we can create feature vectors. We can create image embeddings from a picture. So those are all pre-trained models that are there for images. So we don't have to worry about that. That's another topic altogether. But idea is once we extract the images from the respective documents, we can use embedding models to take these images and extract embeddings out of it. Similarly, we can also do the same thing for JSONs. These are basically you know, uh, these are the tables, the tables. There's some JSON objects that are also there, by the way. Anyways, we can do the same thing for the JSON objects also. There are tables, and this is how we extract from the tables. Okay, you can see. So the Llama parts will do everything for you. We are not doing anything manually. So the parser has automatically extracted all the pictures, all the tables, and see these are the tables we have right now, and all the text. So Llama parse has done all this for you. Okay, so now that we have extracted and separated all the required modalities, let's process each of them starting with text. So now we start the processing. So we save them in the Chroma DB now. We do the chunking. See, we take the text and we create the chunks. 883 chunks are there. And now we save it in the vector Chroma DB. Straightforward. And now the rest of the process follows. Okay. So some of the parts here are related to advanced retrieval techniques, which I will talk about later. I will talk about advanced retrieval techniques later on, but you can get the idea what we are trying to convey here overall, generally. Okay. I've also explained semantic chunker. Remember, I talked about something called semantic chunking. So semantic chunking is basically not a fixed size chunking. So far what we discussed in the demos was something called fixed size chunking. See, instead of chunking the text with a fixed chunk size, so we were doing that, right? So every 512 characters, we try to create a chunk. Every 1024 characters, we create a chunk. So instead of chunking based on a fixed size, what we do is we chunk based on the semantics, based on the meaning of the documents. So that's the way how we go about it. So we instead chunk based on the meaning of the documents. That's the way how we do this. Okay. So this is the chunking that we have done. And then rest of it is very, very similar based on some advanced retrieval techniques. So once I discuss this part of the discussion now, this will be another 15, 20 minutes what I will talk about. So the rest of the notebook just talks about the advanced retrieval techniques. So this is the demo of the advanced retrieval techniques. But otherwise, the most important objective of this particular notebook was to highlight to you how we work with a multimodal system. So if we have different types of data, if we have tables, images, text all together, how we can use something called a LlamaParse to take them separately and create embeddings for them separately, right? So that's the way how we can work it out. Okay, and you can see here just one sample example I wanted to show you how the final system will work. This is a lot of code I know, but it's all the same. You can see the final thing how it will look like. This is the RAG on the multimodal data that we have done. This is the final retrieval that we have done. You can see how the RAG system will actually work out. You can see how to do LTD, LTP, and LTD induction effect, synaptic strength, and morphology. So this is again some completely lot of technical jargon. I don't think anybody in the class understands what these things mean. Neither do I. But this is again some biology field, I think. Okay. So given this question, what we want to do, see, we want the retriever to retrieve fetch at most 3 images for the query. So we want to fetch the pictures and we also want to get the text. So this is what actually happens in a multimodal system, right? Today, if you when you go and run these queries in a GPT, so what happens in a GPT model is also this. So the GPT model also does something, exactly, something very similar to this. That's the idea. Okay. Yeah. No. It's not open source. It's only open source up to a limit. They have a free tier. They have a free tier. You can just log in with your Google account. There's a free tier, but it is paid. Correct. But there's an API key. There's an API key we have to provide. See, that way even OpenAI is also a Python package, but that doesn't mean you can use OpenAI services for free. Make sense? Yeah. Yeah. You have to. There's a section you will see that I actually did not give the API key here, but you have to mention the API key. Otherwise, it will not work. Okay. Yeah. So you have to go to the website and there's a way to create the API key there. Okay, so this is the final result that I'm getting. You can see how to do LTD and LTP induction. So when I write this prompt, this is the kind of response I will get. Okay, so you will get the text response. So the model beautifully explains what is LTP and what is LTD. It gives a text response from my document data. And it also gives me an image response. Remember how I told you fetch at most 3 pictures? See how it has fetched me the 3 pictures. Beautifully, it has answered that question. So it has explained the topic and it has gone and explained to me what it is. Okay, so now you can relate it back to that fin.com that we were discussing yesterday. Remember that fin.com where I said what is a confusion matrix? And I think slowly you can start to relate to what's happening. So there also it is some kind of a retrieval technique where it is based on the question I'm asking. On one hand, the model is retrieving the text answer. It is explaining what is the confusion matrix, what is the classification report, and it is also returning back one picture. It is returning back one image from its repository, from its relevant chunks. It's giving me one image, which explains what the confusion matrix actually relates to. Okay, so that's the way how we can understand how the system is working behind the scenes. Okay, so this is actually a beautiful application. You can see here I've actually kind of completely done the whole thing from scratch. So how to do LTP and LTD induction effects, synaptic strength and morphology. So this is the kind of result I want. So user will ask this question and the model will go and answer it in text and then also give the pictures. Beautiful, right? So, and also give the table. Here I also did the entire thing. So first, based on the question, the model will return the text answer, it will return the image answer, and it will also return some tabular answer. It will also give a table which kind of highlights something related to that LTP, LTD. God knows what that means, but whatever that is. Okay. So you can see that this is how we did the whole end-to-end process.